Let's dig a little deeper into plate tectonics and look at convergent plate boundaries, when two tectonic plates come together. First experiment that we're going to do in our kitchen today involves making some pizza dough and some materials that were used hundreds of years ago by the pioneers to survive their travels across the countryside. Now that we have our pizza dough ready and prepared, we've got our hard tack ready, we've got our continental and our oceanic crust. Now what we need to do is push them together and simulate collision. Now in real life, the Earth's continental plates move about 2 millimeters a year, so it's about the same amount that your fingernails grow every year. And so we've got to speed that up a bit. But what we're going to do is Allie and I are going to simulate the collision of these two pieces of rock, okay? And so I am going to push this way, and the ocean crust is going to ride, and we're going to try and push them straight into each other and just see how the two sides change during that interaction. Now I want to point some things out before we do this. This is a fairly flat blob of continental crust, and this is a fairly flat blob of ocean crust. And let's see how it changes as we do this. So we're going to now start to push these together. Okay, you can push towards me a little harder. Okay, and what do you see? You see that the continental crust gets thicker and taller. And what happens? The thin crust goes underneath. Let's stop right there. Okay, and just let it sit. Okay? Now how does this look different? Well, we had a fairly thin piece of continental crust, but now it's risen up high. Okay? And this is true in many collisions as we get mountain building. We've gotten a big uplifted portion of our continental crust here. And this being a more dense, it doesn't want to float up. It wants to dive down. And actually this crust, ocean crust, is now pushed down underneath. In reality, this is also very cold and it sinks. And back here by my hand, it would be closer to a spreading center, which is very hot, which wants to rise up. So think of this like a giant bulldozer. The ocean crust is the blade of the bulldozer plowing up underneath the continental crust and rising it up and lifting it up. So here's what we want to do. We're going to grab our knife and we're going to just cut the end off of the soft part of the continental crust so that it matches there best we can. Okay? And here you can see that if we pick up on it a little bit, you can see that the ocean crust is actually beneath the continental crust. And that's what we see at a subduction zone. A subduction zone is a place that occurs along the confluence, or the place where two plates meet, when a continental plate meets an ocean plate. This piece that's underneath will get very hot now and begin to melt. And as it melts, it will actually fill this mountain range with magma and magma chambers. And often we get volcanoes, and we can kind of pinch up our bread here, because those are where volcanoes would form, where magma chambers would feed lava onto the surface and build up a range of volcanoes. We call that a volcanic arc. And so here with a couple of different types of bread, we can basically show how these volcanic arcs and mountain ranges form, and how this hard, dense ocean crust wants to slide beneath the lighter, less dense continental crust, which is our pizza dough. So as you can see here, with just a few simple ingredients in the kitchen, with just two different types of bread, we've been able to show physically what happens when these two different types of plates in the Earth's crust converge and come together. And fairly reasonable representation of the landforms that are created. Cool. Another type of plate-to-plate collision that occurs in a convergent plate boundary is a continent-to-continent collision. And these are a little different from continent to ocean. We're going to simulate that one the same way though, and see what kind of landforms we get. So Allie, you take that side and I'll take this side. We're just going to shove them into each other. Ready? On the count of 3. 1, 2, 3. As we push together, where do they go? They go up. I keep pushing. Oh, and you get, so now the rocks actually are not forced downward. so much as they're forced up and out. And so if we slowly take our hands away, see what we have left is a big mountain range, if you can see that. Now, the Himalaya mountains are a great example of this. The continent of India is a continental plate, and Eurasia is a continental plate, and the two collided into each other and had nowhere to go but up and out, creating a really high mountain range that sometimes even breaks the mountains next to it, breaks the rocks open and makes mountains. So we get these big deformed belts, if you will, where these blocks of rocks are lifted up. So this is really common in continent-to-continent collisions in convergent plate boundaries. There's one other type of potential boundary that we can see. I'm going to take our continents. These are kind of heavy. They're kind of continentally heavy. I'm going to set this over here. Now let's do this kind. What if two ocean plates collide? This is a little more rare. Sometimes this can happen, but what we get often when this happens is something called transform boundary. Now, transform plate boundary is one that occurs when plates don't go under and they don't go up. Rather, they slide past each other. Because these are so thin and so dense and hard and brittle, they really move past each other very well. And sometimes you will actually get some vertical motion on these faults where even though they're sliding past the stress, I'm actually pushing at an angle. And so it wants to move this way and it's trying, and sometimes it'll pop like this. And think of the ocean on top of this. What happens with all that water that's then lifted and displaced upward? You can get a giant wave called a tsunami. Okay, anytime this vertical displacement happens, we can offset this water and make giant waves, hundreds of feet tall, that race at hundreds of miles an hour and can devastate the coastlines. So sometimes with either continent ocean or ocean plates, you can get these giant tsunami waves, all through the motions of these plates sliding along each other. So just to summarize, we've seen different types of plate boundaries: convergent, divergent, and transform. Convergent, where things come together, where oceans subduct under continental plate. We've seen divergent, where things pull apart, and we've seen transform, where they slide past each other. And if we add all of those back in, what we see is a series of plate motions that make up the entire Earth that are very complex. And those complex interactions give us various mountain ranges and various ocean basins and various deep sea trenches and all sorts of amazing landforms that make the planet Earth so special and amazing to look at. So the next time you look at a map, think about what might be happening deep down to create that mountain or volcano or mid-ocean ridge.